Hi, everyone. Super excited to be here, and thank you so much for joining me for the last session of today. My name is Julia. I'm the PM working on Azure API Center. Today with me, we have Mike, who's a product manager working on Azure API Management, and we're going to talk about API governance. Nice, very interesting, sexy topic, right? In the era of AI. So what are we going to talk about? First of all, we're going to talk about why API management is super important and very critical, especially in the era of AI, and why you should think or at least start thinking about it. I'm going to then jump into a demo about how you can innovate faster with more of an API first or API design first approach. And for this, I'm going to talk to you a little bit about Azure API Center. After this, I'm going to be handing it over to Mike, my co-presenter, who's going to then talk about Federated API Management, how you can govern your APIs from a runtime perspective, and then last but not least, how to make your APIs even more secure in the context of Azure. APIs are everywhere, or in particular, AI is everywhere, right? So Gen AI in particular is everywhere. So you have on one side, on the left side here, you have intelligence applications, conversational agents, content generations, and then on the other hand, you have these backend services, like Azure AI Search, Azure AI Search, and all of these things. So how can you connect these two different front-end versus back-end, right? And the answer is APIs. So APIs are the core for your Gen AI development. And I want to invite you today to start thinking about why, especially in that case, it's so important to make them manage better, to govern them better, and also to secure them better. So what are some of the reasons we should think about this? Unmanaged APIs burden a huge risk, especially in the era of AI. I think we already talked about this. APIs are the backbones of these API or these application developments. So what are some of the risks or potential risks? Unpredictable costs. I think token has become the new capacity or the new currency in AI development, right? So you don't want to be surprised as an organization at some point if you have all of these different APIs, a lot of tokens are being used. So you want to make sure you are on top of what costs are being related to these developments, right? Reliability concerns. So let's say you have very mission-critical applications using these APIs, and you want to make sure that you have them checked. You don't want them to be the bottlenecks. Security risks as well. If you don't have them governed or if you don't have them protected in the right way, you really want to make sure that these APIs are not becoming potential security risks here as well. And then last but not least, governance implications. Governance in terms of API design governance. And we're going to walk through all of these different aspects today. So we want to invite you, we want to help you to build more secure, more compliant, and also more scalable solutions using Azure. And this is where API management comes in. API management as a strategy with picking and choosing whatever Azure service you want to use and that fits towards your API management strategy within your organization. So we have Azure API Management as a service. We have Azure API Center, and we have a lot of integrated services across these different products that can help you build a better, a more secure, and a more compliant solution infrastructure within your organization. So let's look at API management. API management is our gateway solution. It's there to govern and to control your APIs from a runtime perspective. Mike, in a little bit, is going to talk about Federated API Management with Workspaces. Then, on the other hand, you have API Center. Again, another tool in your tool set for a better API management strategy. This tool can help you to extend your API governance from a design time perspective. You can start shifting left more and help using your developers, including them as early in as possible, to create a more compliant APIs and better APIs overall. And then you have a bunch of different integrated Azure services in these products, for example, Azure Policies or Azure Monitor, that can help you build out this better API management strategy here. So let's dig or dive in a little bit deeper. And we're going to start with a short demo explanation about Azure API Center. First of all, what is it? It's a brand new Azure service. We have gone GA this year in May 2024. And overall, we talked about API management being a gateway solution, where Azure API Center comes in being an inventory solution. So Azure API Center is your API discovery, consumption, and governance solution overall. And we don't care about your API type. We don't care about the API lifecycle stage it is in. And also, we don't care about the deployment location. So let's pick an example or a possible infrastructure you might have within your organization. You might be in Azure. You might be cross-cloud. So you might have all of these different deployment locations. So all of these APIs popping up everywhere, being deployed everywhere. And you need a solution where all of your APIs are being managed for better API governance. So this is where Azure API Center comes in. So for my demo, we're going to take on different perspectives. We're going to look at it from an API admin focused perspective, which we're going to start with. And then we're going to shift to our API developer perspective. So we're going to bring and showcase, first of all, different products, but different strategies or different things what you can do with the products as well. All right, so let's switch to my demo here. So as you can see, I'm currently in the Azure portal here. Azure API Center is all about the inventory aspect, right? So via our APIs tab, you can find all of these different APIs that you have previously registered in your API Center. You can do this via the portal. We also have CI/CD support. So we want to make it as easy as possible for developers to bring in their APIs so you can build up this API inventory here. As an API admin, you might have all of these different gateways where you have your APIs deployed to. So that's why with our latest feature, which you can find in the Environments tab, you can start creating a linking concept to these gateways. So as of right now, you can start creating this link to one or maybe multiple different Azure API Management services. So you can go and pick whatever Azure API Management service you want to start this link to, kind of like a subscription model. So whatever happens on API Management side will just be reflected in API Center. So you can define whatever lifecycle stage your APIs are in, and you can also define that you want to include the API definitions, which we're going to use for API governance in a little bit. So as you can see, after this link has been created, it's now set to the state syncing, which means, again, all changes happening on API management side will be reflected. So let's take a peek into API management. Here you can see I currently have 2 APIs deployed into Azure API Management. So let's take a look what this looks like now in API Center. Remember the 2 APIs we previously had? Now you can see just by creating this link, all of these APIs and API management are now showing up in API Center as a linked entity. So whatever happens will be changed on API management side. This is an API governance session, so let's talk about the governance feature in API Center, API analysis. API analysis looks at our APIs from a design time governance. So here in API analysis, you will find all of these different APIs, your different contracts, and we will show you certain error or warning messages. So we will tell you how compliant your APIs are. So how do we define this compliance state, right? So in API analysis, we, by default, enable you with our API linting engine, and we are using Spectral under the hood. So as you can see, by default, Spectral linting is enabled out of the box. This means you can go in, and you can see all of the reports here. We understand every customer has custom requirements, right? So you might have your own rules. You might have your own guidelines that you want to define your API compliance on. So in VS Code, first of all, you can see all of the different APIs. So you have a different perspective to your API inventory. But very important, we're going to talk about these rules here. So you will find in VS Code the same rules that we have previously seen in the Azure portal. You can go and change them, and depending on your requirements, and make sure that these work within your environment. We're using VS Code for the reason because you probably want to locally test and check if these rules work first locally before you're deploying it. So with this integration here, you can make sure that the rules that I previously put in here are actually working, and it makes sense for me to deploy this back to Azure API Center. So right now, I defined 4 different rules. And whenever I see them fit, whenever it works for me locally first, I can then go and redeploy these rules to Azure API Center. So I will go ahead and redeploy these rules. And whenever they have been deployed back to my API Center instance, what does this look like now in the Azure portal? So whenever I refresh, first of all, the rules will be updated. In our execution history, I can now see that these 4 APIs have been updated with the new rules. And I can also, in the rule set view, now see that these rules have actually been applied to. Perfect. So I know as an API admin, you might want to learn more about these certain rules or error or warning messages, so you can go in and you can find a more detailed analysis of these APIs as well. So here you can see every line, what is the certain error that we have just previously deployed to it. So you can go and check out and get more information because before you're going back to your API developer. So now we talked about it from an API admin angle, right? Let's switch and go to our API developer angle here. As an API developer, I'm the one usually building out these web APIs. So again, I'm starting in VS Code here. I have my weatherapp.net API with 1 get operation. So let's use Copilot, and because I'm using our VS Code extension, which can help me create this API contract. So as you can see here, I use Copilot to help me auto-generate this OpenAPI specification. This looks very base minimum, right? I mean, we haven't attached it to any organizational context, so very, very short of an OpenAPI description. I'm excited to share that now with Azure Copilot, Copilot for Azure, you can now do the same, but you can actually enhance that experience and make these API contracts more secure and more compliant. So with Azure, you're able to call into Azure API Center, and you can already tell whatever the output is here, it's already more compliant. It already provides me more context. It's just a better and a more enhanced experience here. So for me as a developer, I can go and build upon whatever Copilot has presented with me or has presented to me. And because we are using Copilot for Azure, it knows that I'm an Azure. I want to deploy this at some point to Azure as well. It will give me this Azure context. So let's take it up an even notch. We talked about the rule sets that I've previously deployed, right? So how can I make sure as a developer these rules are actually used for whatever Copilot is generating me? So by setting my active style guide and by recreating or regenerating this OpenAPI spec file, now we are actually incorporating all of the rules that I've previously deployed. So you can see the 4 rules that we previously had, which is the email contact, it's the description for my operations, it's the operation ID as well, and now I also want to make sure that it's in lower snake case. So all of this already makes sure that my API contract is actually compliant. You will even find a very nice description there, and it calls out what are the 4 rules that now my OpenAPI contracts are actually following off. All right, so we looked at it from a developer perspective, and we made sure my API contracts are compliant from a design time perspective. Now, as a next step, we want to make sure it's compliant from a runtime perspective. And this is where API management is coming in. So I'm going to go ahead and create in my project here a folder, and I'm going to create and use whatever Copilot has generated me. So whenever I deploy this API using my CI/CD pipelines, it's also going to be deployed to Azure API Management. So I'm using the OpenAPI spec file in a JSON format. Best practices is always to use CI/CD pipeline for the purpose of this demo. We are using the VS Code extension to deploy this to my Azure API Management instance. So we've done all of the parts an API developer does, right? Generated the spec file. So now we are switching back to the API admin perspective. The API admin will now find it in Azure API Management. They will see the same GET operation. It has been deployed to API Management, and they can now take it and apply runtime policies. In API management, because we linked it, you can now find the information that this API management instance is actually synchronized. So you don't have to worry about importing the information into API Center. So whenever you go into API Center, the API will just show up, right? Single source of truth stays API management. And in API analysis, you will now find 5 APIs that are being analyzed. And because our developer checked on API governance beforehand, you won't find any error or warning messages, and you made sure that your API is compliant from a design time perspective here. So let's quickly recap what we have seen. The developer they built out their web API. They needed to auto-generate or generate the API specification. So then they checked, still in VS Code, their API contract from a design time perspective, using content or using organizational input from API Center. They then deployed it to Azure API Management, so your API admin can align it with their policies, their runtime policies in Azure API Management. And because the API admin has set up syncing, it will just show up in Azure API Center here as well. With this being said, I'm done with my demo of today. If you want to learn more about Azure API Center, I highly recommend checking this out or getting in contact with me. And with this being said, I'm going to hand it over to Mike. Thank you, everyone.
Hello, everyone. My name is Mike Budzynski. I'm a senior product manager for Azure API Management, as well as probably the tallest person at Microsoft, if you've seen me around. So first, I would like to talk about API ecosystems in organizations. So we typically see 2 types of teams in the API ecosystems, no matter the size of those organizations or ecosystems. On one hand side, we have the API teams whose main role is to manage, create, develop, debug, and publish APIs, optionally manage their own infrastructure. On the other hand side, we have platform teams, and the platform teams prepare the infrastructure for API teams to thrive and fulfill and succeed at their job. They also apply certain governance. They want to observe the usage of the platform. They want to have centralized logging, and sometimes maybe even distribute or split the cost of the platform among the teams that utilize the platform. Azure API Management historically supported 2 types of managing APIs, the centralized API management model and the siloed API management model. In the centralized model, you have all the API teams using the same API management service without isolation of the control plane or data plane. And the platform team becomes the bottleneck that resolves the conflicts that arise in those data planes due to the lack of isolation, in those data and control planes, due to the lack of isolation. And that could, for example, mean that one team takes a dependency on another team's resource, and that resource changes, breaking the APIs. Or in the data plane, for example, one API causes CPU exhaustion on the gateway, bringing all the APIs down. On the other end of the spectrum, we have the siloed model, where each API team is given their own API management service with full isolation of control and data planes. However, that proliferation of API management services is expensive, as well as the governance is ineffective and inefficient, and you cannot create easy, unified API discovery experiences. So the federated API management model combines the benefits of these 2 models without their downsides. Each API team gets a portion of their the API management service, and because it's still a single API management service, you can easily apply governance rules, centralized monitoring, et cetera, as a platform team. Workspaces enable that federated API management in Azure API Management through control plane isolation, data plane isolation, and platform team controls. On the control plane isolation, you can think of workspaces as sort of like folders where you have APIs and related resources that you assign permissions to a specific team, to one workspace. On the data plane, you may have a dedicated gateway for each team, or you can have a shared gateway bringing one of the aspects of the centralized API management to optimize the costs. On the platform team controls, you have the unified developer portal for the discovery of APIs within or outside organization. Across all workspaces, you have all APIs policy to enforce certain API runtime behaviors, for example, caching, authentication, authorization, throttling, and you have unified centralized logs and metrics. This is a short diagram, just to visualize the concept. On the service level in API management, you have concepts like developer portal, logs and other API team platform controls. And on the workspaces side, inside workspaces, you have APIs, policies, logs, named values, and so on. And then each workspace is connected to a gateway for the runtime of APIs inside that workspace. And I'm excited to announce that as of yesterday, we now support shared workspace gateways. So when we first announced workspaces in August, each workspace required a dedicated API gateway for the full isolation of data plane between the teams. Now you can associate up to 30 workspaces with a single gateway, and that allows you to reduce the cost of federating API management if you don't require for full API runtime isolation. It is up to you to balance the risk, security, and cost with this model. So for example, for mission-critical workloads, we recommend using dedicated gateway to make sure that other teams will not exhaust resources on that gateway impacting mission-critical APIs. For non-critical workloads, it's a good idea sometimes to share that gateway to optimize the cost. Also, you can use different gateways for different use cases or networking requirements. For example, one gateway for internal APIs, another gateway for external APIs with different VNet configurations. This functionality is now rolling out and will continue to roll out through December and January. You can check out the link on the right-hand side for more information. And I would like to invite you for a short demonstration here. This is my API management service in the Azure portal. And I'll navigate to workspaces in this API management service just to demonstrate some of the functionality. We already have one workspace created for the AI team. That is the team that's responsible for creation and management of AI APIs in the organization. And that team already has a chat API published in this workspace. As you can see on the left-hand side, you also have other resources that you can manage within the workspace, such as products, subscriptions to those products, et cetera, fully federating management of those APIs to the team that owns the APIs. This workspace is associated with a gateway called 𝗦𝗽𝗲𝗸𝗍𝗑 API. And there is only one workspace associated with this gateway. This gateway is publicly accessible, but you can also select from a variety of networking options. And let's go back to my workspaces here. And I will create another workspace in the same API management service. This will be a workspace for the team that manages pet store APIs. So if you're familiar with the pet store example of Open API specification, this is exactly the fictitious theme that we are using here. And inside this workspace, we'll publish the pet store API. So let's proceed now to the second step of workspace creation, where we associate a gateway of this workspace for runtime APIs. This new functionality is to add an existing gateway that is already used by a workspace. So that wasn't available before this conference. Now you can select this gateway that already exists and already has the AI workspace on it and deploy this workspace to the same gateway. And I'll proceed with creation of this workspace and association of the gateway. This step usually takes several minutes, around 5 minutes or so. But for the purpose of the demo, we cut out this waiting part. And once it is created, we'll navigate directly to this workspace to publish our pet store API. So this is probably the same interface that you're familiar with from the API management service. We can import Open API specification. This is the pet store spec, available on GitHub, open source. So we'll import that. We'll rename the API to pet store. And click Create. And we also have to update the backend URL for this API because of the spec. It's actually pointing now to GitHub because of a relative path. So we'll update the backend of this API to the pet store endpoint so that we can actually test if the API is up and running. And before we test the API, we'll also create publish it with a product in API management. So product is sort of like a concept where you bundle APIs and you can get credentials to a specific product. In this case, we'll call it Pastor APIs, and mark it as published in the developer portal. And now this product is also managed by the team that operates within this workspace, and all the subscriptions to this product are also in this workspace. So I can copy the subscription key that was automatically created for administrative purposes, can copy that key and use it as a credential to call my API to see if it's working. So I'll call one of the get methods here, input the key, and as you might have noticed, the URL of this API is the same as the URL, the host name of the gateway that hosts both AI APIs and this Pastor API. And now, we got a response 200 OK. So that was working. One more thing, with the product, we'll publish it to the developer portal. So we'll set the visibility controls. We'll make this product and API visible to both users that are logged in and not logged in the developer portal. And let's go to the dev portal that is built into API management that you can fully customize. And let's see if our API is there. And when you click on the APIs tab in the menu, you can see that the Pastor API is now published in this unified developer portal, for example, within organization or outside organization, whatever your business requirements are. And it has the same set of methods with the full open API specification contracts. Now, exciting part, another announcement, Policy Toolkit. So this is a early release of a tool that allows you to write API management policies in C#. It has 3 sections here in this file. I have a file for all APIs policy. So I'm now wearing a hat of the platform team member, trying to enforce some behavior across all APIs, across all workspaces. And I have 3 methods here for inbound, outbound, and backend processing policies. I will start with creating a function, a policy expression function, that will return whether a request is originating from a company IP address. So the function is relatively simple. It takes expression context as an argument and will return whether the request IP address starts with 10.0.0. And now I can add or enforce a behavior to add a header, for example, in the outgoing response from API management, whether the request for that response has originated from a company IP address. And of course, you can do a similar thing with other policies like caching, rate limit, and so on. This is just a simple example of set header. So if request has originated from a company IP address, context set header response scope will mark it as internal. And then we'll repeat similar logic in the else statement, except that we'll say that response scope is external. So this policy, again, will add a header across all APIs, all requests, across all workspaces. And now I can open a command line tool, and I can probably also do it from Visual Studio Code. I can compile the C# file into the policy XML file that API management accepts as input. So compile it to the language of API management. So very simple command, one-line command, and it generated a policy XML file with the policy that I wrote. As you can see, it's a nested policy with when choose statement and the set header policy. And before I publish it, this policy, before I upload it, I will also test it. So with this tool, I can also test my policy. I can create a test class and a test method, for example, for my policy expression. I will create a mock expression context, and I will do two test operations. So one will assign an IP address that starts with 10.0.0, and the policy expression should return true. So I will call it assert is true, that the function is returning true. And now I will repeat the same process for a different IP address, except that now it should return false. So let's choose a random IP address, and except it will now be assert is false, that it is not originating from a company IP address. All right, and I run a .NET test command, and as you can see, my test has passed, so I was able to write a unit test for my policy expression with this toolkit. And lastly, just to check if it's working, we'll upload this policy to API management. Normally, I could do it through CI/CD, for example, with API Ops toolkit. In this example, I will just copy it and paste it using VS Code. So I'll open my API management service in VS Code, click on the global policy, and paste this command. And I can do it because I'm in the development environment, right? So I don't need to go through CI/CD pipelines for production environment. And let's test if, in fact, this policy is working. So we'll call the same API from within the workspace. And first, we'll check that this policy is actually applied in the API management service across all APIs. So the upload of the policy worked. And now let's go to the pet store workspace, copy the subscription key, and let's make a test call. So we'll call the same operation here, paste the subscription key, and the response is 200 OK, and it does contain the response scope external header, so the policy enforcement worked. All right, if you want to learn more about shared workspace gateways, there is a blog post announcement for it, as well as we also have a blog post for policy toolkit. So please check this out. It's on Tech Community, our Azure Integration Services blog. All right, now onto runtime governance. So we touched on that a little bit with the set header policy. Now I want to talk specifically about AI APIs and the governance of AI APIs. Julia talked about some challenges. And now with API management, you can fully enable AI APIs by increasing cost efficiency, reliability of the AI APIs, security, governance, and developer enablement. In addition to that, you can also integrate with other Azure services like Defender for APIs, Azure Policy, Azure Monitor, and so on to enable AI APIs even more. With API management, you can maximize the potential of AI APIs in several aspects. So on the cost efficiency front, first of all, you can get visibility and control over the costs. So you can apply policies that limit token usage on a short-term time frame, as well as longer time frame, the quota, as well as log consumption of tokens to gain the visibility and attribute the costs to specific users or use cases. You can also use semantic caching policy to return cached responses for semantically similar prompts. Therefore, those requests will no longer go to your AI services. The cache response will be returned from API management. High reliability, you can geographically distribute AI services on the backend and use a circuit breaker pattern to break that circuit for services that are experiencing an outage. For security, first and foremost, you have much finer control with credentials per user instead for the whole AI model or AI API. And you can also use some of the built-in controls in API Management and Microsoft Defender for APIs. And developer enablement with policies, with developer portal, and enhanced governance with some of the aspects that we already touched on. So these are a few options in API Management that allow you to take better control of AI APIs. And we'll jump here to a demo. This demo is a little quick, but you can also find some of it online in our documentation. I will share the links right after this demo. So first, we are importing an OpenAI API into API management. It's a very simple process to import that API, and we'll also select the checkbox to make sure that this API is compatible with SDKs. This appends OpenAI at the end because some of the SDKs expect that suffix at the end. Now, also from the creation experience, you can apply some of the policy that we just talked about. This policy allows you to limit the token consumption. In this case, I'm limiting it per subscription, which belongs to a user, and on a short time frame to 500 tokens per minute and 10,000 tokens per week or month, or what's selected there. And then I can also apply the semantic caching policy, as well as add metrics for the token consumption. So I can better visualize who's consuming those AI APIs. So the API creation is quite quick. It really took us 20 seconds to open an OpenAI API into API management and apply these policies right out of the box. And as you can see on the right-hand side, we have those policies applied in the inbound and outbound sections of the policy file. So let's test this AI policy. We'll run a test, and this test will basically load test the AI API. And we should actually start seeing failures because we applied a token limit policy to limit the consumption of tokens per subscription to 500 per minute. And as you can see, it starts to returning 4 to 9, which means that the requests have been throttled. And the token consumption plateaued around 500 tokens for my specific subscription. So that gives you better control over costs, making sure that the costs don't exceed certain budget. Now, let's take a look at the load balancing and circuit breaker patterns. In this example, I have 2 backends for AI APIs, and I'll enable circuit breaker for both backends. And what that means is that if the response is between 400 to 499 in terms of the status code, I will automatically fail over to a different backend. And this will happen for 15 seconds, and then I will retry contacting this backend again. So let's click Save, and we'll do the same, repeat the same process for the other backend. So this will be 2 of the AI backends that are geographically distributed in different regions to increase availability of my AI APIs in case, for example, there is a regional outage, or in case I make, for example, a configuration change that breaks one of the backends. And so circuit breaker has been applied. Now I will create a load balancer pool, a backend pool. So I will assign both backends to the same pool, which tells API management, OK, those backends are equivalent. We will use them as part of the same pool. In case one trips with the circuit breaker, we'll try the other one. And you can have them equal, or you can assign different priorities to the backend as well as weights. So let's assign priorities number 1 and 2. This will inform API management which of the backends is preferred. All right, so we'll copy the name of this backend pool, update our AI API to actually use this pool instead of one backend that we just demonstrated before. And let's call it. So you should see that some of the requests, once the backend circuit breaker is stripped, some of the requests will start going to a different backend in a different region. So let's run the test. And in the results, yeah, as you can see, the first one went to a different region. Then you have the second region for a few other request batches, and then we are back to the first region. Then the circuit breaker tripped again, and so on. And lastly, semantic caching. Semantic caching allows you, again, to return a pre-computed response for a specific prompt that's semantically similar. And this reduces the latency of this response, as well as saves you the cost. All right, so what's new is the enforcement of token quotas. So you can now enforce token quotas on a longer time frame as well. For example, day, week, month, hour, in addition to enforcing it per minute. What's new is also support for GPT-4o in API management. So some of these capabilities for Gen AI mediation are also available for text and image-based input for GPT-4o. And one thing that we did not demonstrate is that you can also use Azure AI Inference API, so not only OpenAI models, but also other models in Azure AI Studio, for example, 𝗲𝗲 from Microsoft, or models like Llama and so on. If you'd like to learn more, here's a bunch of links to get started with Gen AI capabilities, from documentation to labs that walk you basically through the same set of scenarios that I have just demonstrated. Awesome. Now, a little briefly about API security, which is also super important nowadays as the cost of data breaches is increasing every year, and they're also more and more frequent. First of all, API management contains comprehensive controls for API security to protect you against OWASP API top 10 threats. This is a revised documentation that we just published a couple of weeks ago that follows the new OWASP API top 10 guidance from 2023. So it has a set of recommendations for the controls you can use. However, if you want to fully build a fully secure API landscape, you should layer your security. So you should use the controls in API management and the controls provided by other Azure services. For example, Microsoft Entra, Azure WAF, API Center, and Microsoft Defender for Cloud. Microsoft Defender for Cloud has a plan called Defender for APIs that allows you to centralize security insights for your APIs across API management services, identify which APIs serve sensitive data, which APIs are dormant, unauthenticated, externally exposed. It helps you prioritize the risk remediation, and it also, first and foremost, helps you detect threats at runtime. So it creates a machine learning endpoint for each of your API endpoints, a machine learning model for each of your API endpoints, and those machine learning models detect a bunch of patterns, for example, data exfiltration. So this allows you to protect against those threats. Now, also new, as of Microsoft Ignite now, you can enable some of the Defender for APIs functionality as part of Defender CSPM plan. So if you don't need runtime threat detection, you can enable API security posture analysis and some other features as part of Defender CSPM plan. You can learn more using this link at the bottom. Also, new announcement. Now you can start using Premium V2, Azure API Management Premium V2, a new tier for enterprise API programs at large scale, especially with improved VNet injection over Premium V1 that does not have a requirement to open traffic to internal dependencies. It also offers faster deployment times and scaling, and is available for preview, for testing. You can sign up for public preview access using the link aka.ms/premiumv2. And lastly, key takeaways from the session. Effective API governance is critical in organizations to ensure high reliability of APIs, compliance of APIs, security of APIs, and it should not hinder pace of development or innovation. It should actually accelerate, like Julia just demonstrated, with, for example, shifting left some of these processes. Federated API management allows you to federate the management of APIs to the teams that own APIs while maintaining central controls for the platform team to enforce governance, and you can enable that with workspaces in API management. AI runtime governance with API management allows you to keep costs of intelligent applications in check, as well as govern those APIs, secure them, ensure high reliability with load balancing and circuit breaking. API Center allows you to audit and enforce API design compliance, as well as shifted left for use by developers while they're creating APIs. And you can also use other integrated Azure services to achieve even a better picture implementation of API governance, for example, Azure Policy, Azure Monitor, Defender for APIs, and so on. And lastly, a bunch of most important links from the session. To get started with Gen AI gateway capabilities, I recommend checking out this lab, shared workspace gateways announcement. In case you would like to learn more about API Center, in the bottom left corner. And we also would like to invite you to our live stream on December 12th where we'll jump deeper into some of these announcements, and we'll also take your questions from the audience. And that will be hosted on YouTube. And with that, we don't have a time for Q&A, so feel free to stop tomorrow at our booth in zone number 2, and I'll be happy to assist you there. Thank you very much.